Alright, in this video I'll be going over the problems that aren't covered in the other videos that I did for the Test 7 review. So the first one is number 1, and so here we're dealing with composition of functions, and it's important that you know how these are read. This is read f of g of -4, which means f of g of -4. So sometimes I'll just do this. So the first thing we want to do is plug -4 into the g function and see what our output is. So if we plug in -4 here, we're going to get 16 minus 9, which is 7. So this becomes f of 7, because g of -4 is equal to 7. So now you can see we're plugging 7 into the f function. I'll do that right here. So the f function doubles your input and adds 3. So it'll be 2 times 7 plus 3. That's 14 plus 3, which is 17. And so our final answer is 17. All right, on letter B, this is read g of f of x, which means f of x is being plugged into the g function. This is also read g of f of x, just like this. So again, if it helps, sometimes people like to do this. So f of x is 2x plus 3. So we're plugging 2x plus 3 as an input into the g function, because f of x is equal to 2x plus 3. So what does the g function do? It squares your input and you subtract 9. Well, here our input is 2x plus 3. So you're going to have to FOIL this out. So we'll get 4x squared plus 6x plus another 6x is 12x. And then 3 times 3 is 9. So if you FOIL this out, you get 4x squared plus 12x plus 9. So this is 4x squared plus 12x plus 9. Don't forget the minus 9 here. So our final answer is 4x squared plus 12x. Normally when we plug in a number as an input, our output will be a number. If we plug in an expression, like in this case 2x plus 3, we expect our output will normally be an expression as well. All right, let's move on to number 5. So somehow I've overlooked doing these in the original video that I did. So this is an exponential function, and we learned, and it's what I call the basic exponential function. It's just a base to a power. And so what we learned is we want to choose x to be -1, 0, and 1. Basically, the y-intercept will be when x is 0, and then we find a point on each side of that. So if I do plug in 0, f of 0 would be 3 to the 0 power, which is 1. If I plugged in 1, we'd have 3 to the 1 power, which is 3. If I plug in -1, 3 to the -1 power is 1/3. But one thing we learned is these two numbers will always be reciprocals. So once you have the 3, you pretty much already know that's going to be a third. Now this is what we expect with an exponential function that has a base greater than 1. It's going to go through 0, 1, and we're going to have exponential growth. Notice on this side we're at 1, 3, and on this side we're at -1, 1/3. We also know there'll be an asymptote on the x-axis. And so our graph looks like this, which is what we would expect anytime we have a base that's greater than 1 and there's no kind of shifts or any kind of other transformations. So that's that one. Now here I'm going to change to the y notation. It turns out that it can be kind of a challenge to pick points, for x here, to pick good values for x and solve for y. So, and the other thing is we learned with exponential functions, we choose x to be -1, 0, and 1. With logarithmic functions, we're choosing y to be -1, 0, and 1. The other thing about natural logs, remember exponential functions went through 0, 1. Logarithmic functions we expect to go through 1, 0, and you'll see that this one will. So it turns out though this is a little bit easier to do if you switch to exponential form. It's easier to pick points. Remember, this is a base of e, so basically we have e to the y power equals x. That's the exponential form of this equation. And so if we choose y to be 0, like we did here, x will be e to the 0, which is 1. If we choose y to be 1, e to the 1 would be equal to x. And we said e is about 2.718. We'll just say 2.7. You could certainly use your calculator. Just do second ln, and that's how you can take e to a power. If you take e to the -1 power, plugging in -1 here, you'll see that x is about 0.36, or rounded to 1 decimal place, we'll go with 0.4. So again, with logarithmic functions, we're expecting to go through 1, 0. We're also expecting to have an asymptote on the y-axis at x equals 0. And so we have, let's see, 0.4, we're at -1. So not quite half the way, we're down here. We did 1, 0, and then 2.7. So that'd be around here, we're at 1. So about 2.7, that's 1, 2, about 2.7, and then 1 would put us there. And so our graph looks like this. And as we talked about in class, basically, when I think of this function, it reminds me of the ET function. Remember, y equals the square root of x goes like this. The only difference is, notice it goes through 1, 0, and then down here it's approaching this asymptote. So it's similar, but not the same. All right, we got one more problem to go. This is the last problem that's not covered in the original videos I did. Number 16. So it says, in 2010, a town with a population of 25,000 finds that its population is growing by a rate of 0.75% per year. Find the following. So first of all, find the exponential function for the given information. Well, first of all, we have a formula for the population function. That's this one here. It's similar to the PERT formula, but the PERT formula is used with interest rates, compound interest that's compounded continuously, whereas this is for population growth, which is what we have here. So it's P of t, which is the population after t years, is equal to P naught, the starting population at time t equals 0, times e to the kt power. So in this case, in 2010, that's when we're starting. That's basically time 0. The population is 25,000. That's going to be our starting population, or P naught. So let's go ahead and put that in. And the growth rate is 0.75% per year. That's less than 1% per year. Basically, take 0.75 and move that decimal 2 to the left. It's 0.0075. Be careful when you write your percent as a decimal. Move that decimal 2 to the left. So this is times e to the 0.0075. and then t we don't have here. We're just writing the population function, or the exponential function, which is called a population function. So p of t is equal to this function here. Now here it says estimate the nearest person the population of the town in 2024. Well, in 2024, if we started in 2010, that means 14 years have taken place. Remember, time zero was when the population was 25,000, and that was in 2010. So 14 years have passed. So we're finding an estimate for that population. So P of 14, so it's 25,000 times e to the 0.0075 times 14. Let me get my calculator. Oops. Okay. Let's see. So it's 25,000. We'll hit second ln. That's how we put in a power of e. So it'll be 0.0075 times 14. Now, if you're using one of the older TI-84s, you may have to put parentheses around this product so that it takes e to the power of that product. Let's go ahead and hit enter. We get 27,767.7, well, we could say about 0.8. So since they're saying round to the nearest person, this would be 768. 27,768 people. All right, let's move on to the next problem. Last problem here. Oops, let's move this just a little bit more. Okay, so estimate when the population will be 30,000. Now notice, if you look at the last problem, after 14 years, this would be our population. And this is what we would call P of t. We want this number to be 30,000. So actually, it looks like it's going to be a little more than 14 years. So basically, we'll take our original population function. We'll plug in 30,000 here. P is still the same. P naught is 25,000. This will be, let's see, our growth rate is 0.0075. By the way, it does say estimate when the population will equal this amount, so we're looking for t. And so this is the equation that we're solving. We just plugged in 30,000 for P of t, 25,000 for P naught, and 0.0075 for k. Now, when you look at this, normally when we solve exponential functions, quite frequently we have to switch forms, switch to logarithmic form. Problem here is the 25,000, because here we have base of e, exponent answer. So this 25,000 is an extra number. Let's divide by 25,000 on each side, and we can get rid of that. And so when you do that, you get 1.2 equals e to the 0.0075t. Now notice we have base, exponent, answer. We have an exponent, or I'm sorry, a variable in the exponent. We're going to need to switch to logarithmic form in order to solve for t. So this is log base e of 1.2 is equal to 0.0075 t. Remember, it's base, exponent, answer, And so everything's in the right place. The only thing is we would write this a little differently. We don't write log base e. We write natural log of 1.2 equals 0.0075t. To get t by itself, we have to divide by 0.0075. When you do that, you should get about 24.3. It says, when will the population be 30,000? You could either say in 24 years, or the other way you could answer this is, notice it's 24 years from 2010, so that would be in the year 2034. Either of these answers would be fine. Whoops. All right, so that's it for this video. Hope that helps.